Hello there, welcome to CSSchool channel. In this video we are going to look at max distance problem. The link of this problem is in the description of this video, so try to solve it on your own, and if you can't solve it, come back to this video. So here is the problem statement which is shown on the screen. Given an array of integers a, we need to find maximum of j minus I subjected to the constraint a of I is less than equal to a of j. So here is the input which is given to us, the array 3, 5, 4, 2, and the output is 2. Okay. So in this array, we need to find two numbers such that the difference between their indexes is maximum. Okay. And the second number is greater than the first number. So here, the two such numbers are 3 and 4. The difference between their indexes is, the index of 3 is 0, the index of 1 is 5, and the index of 4 is 2, right? So the difference between their indexes is 2 minus 0, which is 2. And the second element is greater than the first element. So how did we reach to this solution? Okay, so what we can do to find out this solution, we need to consider all the pairs of numbers in this array. So let's start with these three. Okay, so which are the pairs of numbers that you can create with these three? Okay, we can create 3 3, right, 3 5, 3 4, and 3 2. So 3 3, 3 5, 3 4, and 3 2. So these are all pairs of numbers that we can create with 3. Similarly, let's start with 5. We can create 5 3, 5 5, 5 4, and 5 2. Cool. Similarly, let's start with 4 now. So 4 3, 4 5, 4 4, and 4 2, right? Similarly, we can start with 2 and we can create 2 3, 2 5, 2 4, and 2 2. Okay, so these are the numbers that we can create, and I have listed these numbers here. So now let's start considering this 3 3 pair. Okay, so what is the index of this 3? Well, the index is 0. And what is the index of this 3? Index is 0. The index of the first number is denoted by I, and the index of the second number is denoted by j. So is aj greater than equal to ai? Well, that's true, right? Aj is greater than equal to ai. So the first condition is getting satisfied, which is a of j is greater than equal to a of I, right? Then we need to calculate j minus I. Cool. J minus I is, j is 0 and minus I is 0, which is 0, right? So 0 is the output for j minus I. Similarly, we need to do this calculation for every single pair in this array, and we need to find maximum j minus I. Let's start finding j minus I for each of the pair. Okay, so what is the value of I here? Well, 3 has an index 0, and what is the index of 5? It's 1, right? Is aj greater than equal to ai? True. 5 is greater than equal to 3, right? So let's calculate the difference between j minus I. It's 1 minus 0, 1, right? So let's do this again for this number 0, 2, right? So is aj greater than equal to ai? True. 4 is greater than equal to 3, right? So let's calculate the difference of indexes. 2 minus 0, right? Okay, so now let's see this pair 3, 2. Is aj greater than equal to ai? Well, 2 is not greater than equal to 3, right? So we need to discard this pair, as this pair doesn't fit to our requirement. Okay, now similarly we need to do this for all these pairs. Okay, so let me do this. So I have calculated distance between pairs for all the elements in this array. Okay, whichever elements were not qualified because a of j was not greater than equal to a of I have marked them with cross. Okay, 5 3 does not qualify, 5 4 doesn't qualify, 5 2, so on and so forth, right? And I have calculated the distances between them, and I have write those distances in front of each of the pair. Okay, so which pair has the maximum distance? Well, this does. 2, the distance between 3, 4. So this 3, 4, 2 minus 0, 2, right? So that is our answer, 2. Similarly, let's look at another sample input, which is an array 3 4 1 2 5 given to us, right? So I have generated all the pairs which are possible in this array here. Okay, your task is to pause the video now and calculate how did we get 4 as an output. Okay, which pair gives us 4 as a maximum distance between two elements. Okay, so do this and come back to this video. So the pair which generates the maximum distance is this one, 3 5. The index of 3 is 0, the index of 5 is 4, and a of j means 5 is greater than equal to 3, right? So what's the difference? 4 minus 0, which is equal to So the first approach by which we can solve this problem is the brute force approach. We will do something which we have just done in our sample inputs and outputs. Okay, we will generate OR pairs of numbers and we will calculate the difference between their indexes if input of j is greater than equal to input of I. Okay, so what we have done, we have done two for loops, I from 0 to n and j from 0 to n, and we have checked if input of j is greater than equal to input of I. If that's the case, we have calculated answer, which is max of answer, which is initialized with 0 comma j minus I. Okay, so it gives us a maximum of either answer or j minus I, and we have returned that answer at the end of the function. So what is the time and space complexity for this approach? Well, the time complexity is O of n square. Why O of n square? Because we are running two for loops which are inside one another. Okay, and what's the space complexity? Well, the space complexity is O of n, as we are not using any extra space. So can we optimize this approach? Well, yes, right? So let's look at how we can optimize this approach. So where we should go from the previous approach. If you observe, there is one constraint that we need to solve, that is a of j greater than equal to a of phi. So there should be a way to make that constraint easier to check. Okay, so is there a way in which we can make sure that a second element in the array is always greater than the first element? Well, there is actually, right? What if we sort the array? But sorting has a one problem. We lost the indexes. Okay, sorting will change the indexes of each element, so it will get lost. So we need a way to preserve that index. And how can we do that? We can do that by keeping it with the element. So what we will do, we will transform the array into something like this. 3 will be transformed into 3 0. So 0 is the index of the 3. Okay, similarly 5 is transformed into 5 1. Okay, so 1 is an index of 5. So again 4 is transformed into 4 2. So 2 is an index of 4, and 2 is transformed into 2 3. 3 is an index of 2, and after that we sort the array based on the first element. So after sorting, it becomes 2 3. 2 is the first element and 3 is the previous index of the 2. Similarly, after that we have 3 0, after that we have 4 2, after that we have 5 1. Now where should we go from here? So consider example of this 3 0. Okay, consider we are considering this as a second element in our pair, jth element in our pair of I and j. So where are all the elements which are smaller than or equal to 3? Well, all the elements lie in this part of the array, right? So what we need to do, we need to find I such as j minus I is minimum, right? We have j here. Okay, we are considering 3 as our jth element, so j is 0. Okay, so we need to find I such that j minus I is minimum. So how can you find that? So we need to just find minimum I in the left hand side of this array from this 3. So j minus I can be as minimum as possible. Okay, consider this example of 4 and 2 as well. Okay, so if we are considering 2 as our j, okay, we need to find minimum I in this 3 elements such that j minus I is minimum. Okay, so which is the minimum I in these 3 elements? Well, it's 0, right? So our I becomes 0, right? And our j minus I becomes, well, it's 2, right? So hope you got the intuition behind the solution that we are going to implement. Now let me just discuss the algorithm with you, and let's look at step-by-step iteration of that algorithm. So now let's look at the algorithm which will help us to solve this problem. Okay, so in this algorithm we need to start with creating pair of numbers and its index, and after that we need to sort the pairs by the value of the number. Okay, after that we have initialized answer with 0, and lmin is the variable which stores the smallest value of I. Okay, and we have initialized that with v0 of second, which will store the element 3's index, which is 0. Okay, after that we have written a for loop which will go over each of the element. In this for loop we have initialized answer with maximum of answer and vi dot second minus lmin. So this is current elements index in consideration, and this is minimum value of I that we have found so far. Okay, and we have initialized lmin with minimum of lmin and current elements index, and at the end we have just returned the answer. So now let's look at the step-by-step execution of this algorithm. Okay, for this we are starting with an input array 3 5 4 2. After that we have added indexes in each of the element, and after that we have done the sorting. In this array we are calling it as v. Okay, initially the value of answer is 0, and we have assigned lmin with a value of v0 of second. v0 is this and its index is 3. Okay, so lmin starts with 3. Okay, after that we are going into the for loop and we are assigning answer is equal to max of answer comma vi dot second minus lmin. So answer is 0, vi dot second is 3, so vi is nothing but I is initially 0, so vi is this element. Okay, so vi dot second is 3 minus lmin is 3. Okay, so this we get as 0 comma 3 minus 3. So we need to find maximum between these two elements, which is 0. So answer is assigned a value 0 and lmin is assigned a new value. So lmin becomes minimum of lmin comma vi dot second. So lmin is initially 3 and vi dot second is 3. So we need to take minimum between these two elements, which is 3 again. So lmin has kept the same value. Now we increment the I. So now we are considering this element. Okay, now we are again assigning answer with maximum of answer, which is 0, and vi dot second is 0 now, right, minus lmin is 3, right? So 0 minus 3. So we need to find maximum between these two elements, which is 0. Maximum between 0 and minus 3 is 0, right? So answer has been assigned 0 again, and lmin becomes minimum of lmin comma vi dot second. So value of lmin is 3 and value of vi dot second is 0. So now lmin's value is changed to 0. So this is minimum ith index which we have found so far. Okay, now we are considering the next element 4 2. So we need to count. So we need to calculate answer again. So answer becomes maximum of answer. The value of answer is 0 comma vi dot second is 2 minus lmin is 0. Cool. So we need to find maximum between these two, which is 2. So answer has been assigned a new value, which is 2. Okay, and lmin we need to set to minimum of lmin. The current value of lmin is 0. Okay, and vi dot second is 2. So we need to set minimum of 0 or 2, which is 0, right? So lmin will have the same value again. Now we are considering the next element, the last element, which is 5 1. Okay, so we need to again calculate answer. Answer is equal to max of answer. The current value of answer is 2 and vi dot second is 1 minus lmin is 0. So we need to find maximum of 2 comma 1, which is 2 again. Okay, the value of answer will be 2, and then we are setting the value of lmin. So lmin becomes minimum of lmin. The current value of lmin is 0 and the current value of vi dot second is 1, right? So it becomes 0 comma 1. So minimum is 0. So we'll keep the value of lmin as 0 only. Okay, so we get the final output, which is 2, which is the correct distance between these two elements 3 comma 4. Okay, so hope you got the algorithm. Now let's look at the C++ implementation for the same. So now let's look at the C++ code for the algorithm just discussed. Okay, so we need to implement this maximum gap function, which accepts vector of integer as an input and it expects integer as an output. Okay, so the first step that we have done in this function is calculate the size of the array. Okay, and we have stored that in n variable. Okay, after that we have declared a vector with a pair. So this will allow us to store all the elements with their indexes. Okay, so we have defined this vector v with a pair 2 numbers. Okay, after that we have run a for loop and we have added a pair with element and its index in this vector, and after that we have sorted the vector as per the algorithm. Okay, after that we have created 2 variables, answer and lmin. Lmin is assigned the value of the first element's index and answer has been assigned value 0. After that we have run a for loop and we have done the steps which we have just discussed, calculating answer by maximum of answer and vi dot second minus lmin, and similarly we have calculated the value of lmin by minimum of lmin and vi dot second, and at the end we have just returned the answer. So hope you are clear with the C++ implementation. Now let's run this code. For running this code, I have written a main function in which I have created a vector a. That vector I have passed to the maximum gap function, and whatever the output that comes, we have printed that output on the terminal. So let's compile and run this code. Okay, so we get 2 as output, which is correct distance between 4 and 3. So what's the time and space complexity of the solution that we have just discussed? So for calculating time complexity, we need to see how many operations that we have done. So we have done an operation of running a for loop first. After that we have sorted the array, and after that we have run another for loop. So it is maximum of these 3 operations, and the maximum time complexity of the operation is required in sorting, which is n log n, right? So the time complexity becomes O of n log n. And what's the space complexity? As we are using an extra space to store these vector pairs, right, we need to consider that in our space complexity. So the space complexity becomes O of n. So hope you are clear with the problem and its possible solution. If you have any doubt, please ask me in the comment section. I will be more than happy to help you. We will be making more such videos in the future, so do subscribe to our channel and stay tuned.